All right, so to review some of the nuclear chemistry, we need to know the difference between nuclear fission and fusion, and we need to know how to tell a difference between the diagram and the equation. So if we look at this diagram, and you'll be looking at this problem in a little bit, a neutron bombards uranium-235, and that uranium splits into two smaller atoms, giving off 3 neutrons in the process. This is an example of nuclear fission because uranium is splitting into 2 atoms. We can represent that with an equation here where one neutron bombards uranium-235, and that produces krypton-92 and barium-141, along with 3 neutrons and some energy. Additionally, we need to know the 3 types of decay, or the particles that can be given off in radiation as radiation. So we have an alpha particle, beta particle, gamma particle. The alpha particle, if an atom goes through alpha decay, then it gives off, essentially this atom right here is going to give off an entire helium atom. So its atomic number decreases by 2, and its mass number decreases by 4, because essentially this uranium atom is losing 2 protons and 2 neutrons from its nucleus, and that's why it produces thorium-231. Beta decay is interesting. If you notice, there's no mass change in beta decay for the mass number, 235 and 235. But there is an increase in the atomic number. The atomic number goes from 92 to 93. Sorry, for a beta decay, it's giving off an electron, but that electron has a unique source where it's coming from. In this process, notice the atomic number increases by 1, and that's because a neutron in uranium is converted into a proton, and that's why we have more protons here. But since it's a neutron being converted, the overall mass does not change, and in that process, an electron is given off of the nucleus. And finally, we have gamma radiation, where there's no change in the mass number or the atomic number, and so that's just where energy is given off. And usually, gamma radiation is paired up with some other form of radioactive decay. Remember, when we are doing balancing equations, it's important that the mass numbers on top are balanced on both the left and right side of the arrow. So notice you have uranium-238 here. So the thorium-234 and helium-4, those mass numbers add up to 238, just as the atomic numbers have to add up to each other on bottom. So 92 here, and then 90 plus 2 equals 92. So that's how we check to make sure that the nuclear equation is balanced. Okay, and finally, the other reaction we want to look at is fusion. And remember, both nuclear fission and fusion produce a lot of energy, much more energy than a chemical reaction does. And so in this example, we have fusion where one hydrogen atom collides with another hydrogen atom. So this is tritium because it has a mass number of 3, and this is deuterium because it has a mass number of 2. They collide together, a neutron is given off, and they form helium-4, so the helium atom. And in that process, they give off a little bit of energy. So this is fusion. So in fusion, think fusing together of 2 small atoms to make a large one. So then we can represent it with an equation here where hydrogen, so deuterium plus tritium forms helium atom plus a neutron that's being given off. So that's fusion. We see this in, this is a reaction that powers the sun, whereas fission is what we see in things like atomic bombs. All right, so that's it. Go ahead and keep working on your Unit 1 review part 2.